Hi guys, good afternoon. I'm gonna discuss about the mathematical problem involving patterns. So let's go to the objectives. Define and understand the concept of patterns on mathematical. Second, identify and differentiate the various types of mathematical patterns. And lastly, we have solve the mathematical problems that involve recognizing and extending problems. So, what is pattern? Pattern is all around us. In mathematics, a pattern is repeatedly arranged of numbers, shapes, or other objectives that follow the specific or predictable rule. Pattern can be related to any events or object like chair, phones, laptop, and even our aircon. And sometimes patterns are also known as sequence. Patterns are finite or infinite numbers. Mathematical problems involving patterns. Numbers permeate our daily lives, forming the foundation of mathematics. They are integral to predicting outcomes, as prediction often underlying numbers patterns. These patterns naturally lead to the concept of function in mathematics, which describe how a quantity depends on another through a specific sequence of a number. One of the most famous number patterns is the Fibonacci sequence, which is 1, 1, 2, 3, 5, 8, 13, and 21, and so on. So, some of the types of patterns are prime number, geometric number patterns, imaginary number patterns, and growing number patterns. And
Let's define what a sequence is. A sequence is basically a list of numbers arranged in a specific order following a rule or pattern. For example, there's a pattern in how numbers are added or subtracted. Common examples include arithmetic sequence. You add or subtract a fixed number each time. Example, 5, 10, 15, 20, and so on. Geometric sequence, where you multiply the same number each time. For example, 2, 4, 8, 16. Even in odd numbers, prime numbers, square numbers, triangular numbers, and Fibonacci numbers are also examples of different types of sequences. In short, a sequence shows how numbers follow a certain rule or pattern. A finite sequence means it has an end. It stops after a few terms. For example, 100, 99, 98, 97, and it stops. While an infinite sequence means it goes on forever. Example, 3, 6, 12, 24, 28, and so on. The dots mean it continues. Now, there are different kinds of number patterns or sequences. We have arithmetic sequence, geometric sequence, and Fibonacci sequence. Each type follows a unique rule. Arithmetic, you can add or subtract the same number, while geometric multiplies or divide by the same number, and Fibonacci adds the two previous terms to get the next one. Now, let's talk about arithmetic sequences. These have a common difference. You add or subtract a constant number to the previous term. This constant number is called the common difference. To find any term in the sequence, you can add or use the formula an equals a sub 1 plus n minus 1 times d, where an is the nth term, a sub 1 is the first term, n is the term number, and d is the common difference. To find any term, use this formula. So, let's try one. If a1 equals 1, d equals 2, and you want the sixth term, plug in the numbers. A sub 6 equals 1 plus 6 minus 1 times 2, and that brings us to 11.
Hi everyone, for now, let's tackle about the difference table. A difference table displays the differences of successive terms. In the first differences, the number are differences between the closest digit above them. Subtract the upper left number from the upper right number. If the first differences are different, compute the successive differences of the first difference. Call the second and third differences. The following examples show how to predict the next term of a sequence. So now, I will teach you how to solve this type of problem. In this given, we have a sequence given, which is the 6, 9, 14, 26, 50, 91. And here is, we need to find the next term. To find the next term, we need to subtract this 6, 9, and we have the answer of 3. So as we can see, hindi pa natin siya nahanap yung same differences. So let's proceed to the second differences. So here, gaya lang ng kanina, kailangan lang natin siyang i-subtract. Makikita natin na hindi pa rin siya same. So let's proceed to the third differences. So here, nakita na natin yung same differences, but the thing is, we need to find the next term of the 91. So, all we need to do is just add here a 5, and ipagpa-plus lang natin siya sa 17 plus 5, so we have 54. Ganyan kung paano mo makuha ang next term.
So, what is geometric sequence? Geometric sequence is geometric progressions or are ordered sets of numbers that progress by multiplying and dividing each term by the same amount each time, and it's called common ratio. As you can see here in the example, 1, 2, 4, 8, and 6. And sa ilalim niya ay makikita nyo kung ano ang ginagawa upang mag-times 2 ito. So, 1 times 2 equals 2, 2 times 2 equals 4, 4 times 2 equals 8, 8 times 2 equals 16. So, it is times 2, so you can get the next each term of the sequence. So, sa next example is 20, 10, 5, 2.5, and 1.25. So, sa example na to is 20 divided by 2 equals 10, 10 divided by 2 equals 5, and 5 divided by 2 and 2.5. So on and so forth.
The man behind this sequence was Leonardo of Pisa, who is also known as Fibonacci. He lived around the years 1170 to 1250 and was one of the greatest mathematicians of medieval Europe. After traveling to several Arab and Eastern countries, Fibonacci learned advanced mathematical ideas, and in 1202 he wrote a book called Liber Abbas, which means the Book of Calculation. This book introduced the Hindu-Arabic numerical system, the same system we use today, and presented Fibonacci sequence for the first time. Now, let's see how this famous sequence was discovered. The rabbit problem, or the origin of the sequence. The Fibonacci sequence started from a simple question about rabbits. Fibonacci posed a question. If you begin with one pair of rabbits and each pair produces another pair every month starting from their second month, how many pairs will there be after month? This led to the pattern 1, 1, 2, 3, 5, 8, 30, 21, 34. Each number represents how the rabbit population grows month by month. The problem was the foundation of what we know called the Fibonacci sequence, a pattern that keeps appearing in nature and science. Next, let's understand how this pattern is formed mathematically. The Fibonacci rule. The Fibonacci sequence follows a very simple rule. Each term is the sum of the two previous terms. And the formula is Fn equals Fn minus 1 plus Fn minus 2. It starts with 0 and 1, so the sequence goes like this: 0, 1, 1, 2, 3, 5, 8, 30, 21, and so on. This is called the recursive sequence, which means each new term depends on the one before.
So there are two types of pattern, which are the shape and letter patterns. So first, let's talk about shape pattern. A shape pattern is a sequence that uses shape like square, triangle, circle, stars, and many more that is arranged in a certain order. These shapes either repeat or follow a rule that we can easily spot. So the second one is letter pattern. A letter pattern is a sequence of letters that follows a rule or repeat in a certain order. It works just like shape pattern, but instead of using shapes, we use letters.
And that's all. Thank you.